All right, we'll go a little bit faster now that we've seen some examples. Example 4, determine R4, the right endpoint approximation, using 4 rectangles for the area under the curve of f equals x squared minus x plus 1 on the interval 0 to 1. So, we don't necessarily need to draw anything here. What we do know is that RA is 0, RB is 1, N is 4, and we do know that delta x is always b minus a over n, so delta x is 1/4. So I'm going to write it like this because this information here allows us to figure this out. After that, we can go ahead and say that we also know that x sub I is always a plus I delta x. So for us, this means we have 0 plus I over 4. Now for the left endpoint approximation, we'll be using x sub I minus 1. For the right endpoint, we'll be using x sub I. And if we were doing the midpoint, we would use the average of those two. So for us, all we need to do now is calculate what f of x sub I is. Well, this is I squared over 16 minus I over 4 plus 1. The right endpoint approximation is always the sum from I equals 1 to n f of x sub I delta x. So if we fill in our information, this is the sum from I equals 1 to 4. This whole expression, I squared over 16 minus I over 4 plus 1 times our delta x, which is 1/4. Which we can then write as 1/64th, the sum from I equals 1 to 4 of I squared, minus 1/16th, the sum from I equals 1 to 4 of I, plus 1/4, the sum from I equals 1 to 4 of 1. Power sum formulas now. This would be 4 times 8 times 9. Oh, I messed that up. This should be 4 times 5 times 9. All over 6. Minus 16 times the power sum formula, 4 times 5 over 2, plus 1/4 times, if we add up 1 plus 1 plus 1 plus 1 4 times, we just get 4 copies of 1, which is 4. So this is times 4. Doing some arithmetic and adding that all together, we should get 27 30 seconds.